The objective today is to use a loop in a program to simplify the expression of repeated tasks. So this is in preparation for the performance tasks where you'll submit some code to be reviewed. Now, before we get into the lesson, let's take a quick survey. On a scale of 1 to 10, 10 being you feel great, how comfortable do you feel with the following two items? The first one says, basically, how comfortable are you writing programs that address one component of a larger programming problem? The second one says, how comfortable are you using code written by other programmers to complete a larger programming task? And then to the right here is a sort of a funny joke. Algorithm is a word used by programmers when they do not want to explain what they did. I think the word abstraction can take the place of that word algorithm in the joke, okay? So abstraction is something we use a lot in class, or I use a lot in class when I don't want to spend much time explaining the details of the thing that we're talking about. Programming teachers use abstraction, but so do actual programmers, all right? It's an important tool because not only does it allow the individual programmer to break down complex problems, but it enables effective forms of collaboration. Once a problem has been broken down into its component parts, teams of programmers, sometimes dozens or more, can attack individual components of that problem in parallel. So your think, write, share here is think of big companies like Bungie, for example. What types of teams would be needed to create a game? And this one is a pretty softball question because if you end up taking the direction of talking about art teams and maybe networking teams and actual math teams, you can take it that way. Or you can think about what a game program would look like and what types of functions, loops, what type of abstractions would be needed within that program. And now I want you to go back and think about what I just said. Abstraction is an important tool in programming, not only because it's allowing programmers to break apart complex problems, but because it enables them to effectively work in teams. So think, write, share, based on the knowledge above, what about abstraction allows for effective collaboration? It says here, abstraction is a simplified representation of something more complex. Although teams really help reduce complexity, this style of programming requires clear communication and a shared understanding of the high-level requirements of the software. If implemented carefully, however, it can be an effective strategy for rapidly producing large and complex pieces of software. And if we have time this year, we'll spend a lot more time on GitHub, where that's the actual purpose behind a website like GitHub, is working together collaboratively on separate pieces of software. So to wrap up here, think, write, share, what's an abstraction, and do you prefer working alone or in teams? I'm just curious. So now we'll move on to group work. Now I say yay because if you really wanted to tackle this on your own, you can. You'll have that ability. Here are some links that you'll need. So I'm going to paste this on Canvas. The first one sends you to a student sample of the create task for the program, okay? And the second one is similar, but it just has the rubric. So if you're a fan of rubrics. But the third link is for you to actually achieve today's DOL. So what is the DOL? You'll basically be coming up with a program, and then you'll need to reflect on each part of the program and write that down. So the first way you reflect is you'll provide a written response that identifies the programming language, identifies the purpose of your program, and explains what the user should expect to see when they run the program. Similar to our performance task where you have to explore an innovation, you'll be capped at 150 words for this part. 2b says, describe the incremental and iterative development process of your program, focusing on two distinct points in that process. So describe the difficulties and or opportunities you encountered and how they were resolved or incorporated. Now in your description, clearly indicate whether the development described was collaborative or independent, and at least one of these points must refer to independent program development. So if you choose to not work in a team today or with a partner, that's totally fine with me, because when you do the actual performance task for the AP test, you will be working on your own, okay? And 2D is the last one. Capture and paste a program code segment that contains an abstraction you developed individually on your own. And mark this with a rectangle. It says the abstraction must integrate mathematical and logical concepts, explain how your abstraction helped manage the complexity of your program. And I'll help you with that a little bit too by giving you examples. So there's your DOL. Essentially all you need is that link I just said to use this. So I'll go to this link and give you some further examples. But if you're pretty much ready to go, okay, go ahead and get started. That's your DOL and you're done for the day. But if you want to stick with me, especially your auditory learners here, I'll go ahead and read a student example of this entire task, and then I'll show you just a little bit of how to get started with that link, okay? So here we are on the link, and basically all I want to show you is that you go down here and click Functions, and then you could drag and drop the function over here. You see I have the settings where I'm not using the blocks. I can change that if I wanted the blocks. I prefer not to though. So anyways, here's where you will begin to create your function, come up with a name, and then here's your commands and you can start building the function from there. Then to easily copy and paste in Canvas, you can show the code and copy it and then paste it. Alright, and here we are now at a student example of this create performance task, and I'll just read what another student wrote and you can kind of reflect on if they are achieving these prompts here. So the first prompt, 2A, provide a written response that does a couple things. Alright, so this student says, the purpose of my program is to draw a randomized beach scene that will always show sand, ocean, trees, clouds, and birds. Every time you run the program, the trees, clouds, and birds are a little different in terms of size and location on the screen. Very good use of random numbers. The language I used is JavaScript through code.org app lab, and that's the programming environment they're using. So that sounded terrific. For 2B, basically describing the development process, okay? This was a group project that we first had to decide what kind of scene we wanted to draw. After we decided a beach scene, we all took one major component to write functions for. So here's the independent part. I chose to make the clouds. I wrote a function to draw a single cloud of a different size, and then I wrote another function to draw several clouds at random locations. One problem I had at first was that my clouds were too random. The size made them look not like clouds. So I had to experiment to find the right random range of values to get what I wanted. It ended up being smaller than I initially thought. Another difficult part I encountered was that we didn't assign anyone to make the background, which meant we didn't know what the location of our individual parts should be. So in the end, someone named Bobby made a background and we agreed on the Y location for the horizon. Almost done here because remember we get to skip 2C. So capture and paste a program code segment that contains an abstraction. I have captured the functions I wrote to draw the clouds called drawCloud and drawAllClouds. These abstractions help me manage complexity in a few ways. First, the parameter size in drawCloud makes me able to draw a cloud of any size. I want with some consistency. Without the parameter, I'd have to either pick a single size for every cloud or make each dot that makes up the clouds have a random size. Instead, when I call make cloud size, I can give it a single random number that it will use for everything. For draw all clouds, I have a loop that calls my draw cloud function several times with a different random number for each time. And also it moves the turtle to a new location each time before calling draw cloud. So this helped manage complexity because without the loop, I'd have to copy and paste the code inside the loop multiple times. Furthermore, if I didn't write drawCloud, then it would be really complex because I'd have to repeat all the code. Writing these functions is an example of compression. And here's the last thing I'll show you for the day. The student, as they were writing out their code, they were doing these comments here, which look really helpful, right? The first comment on line 22 says, everything below are functions written by me and my teammates to support the function calls above. So at the very top are our function calls. I wrote this function and draw cloud size myself. Calling this function will cause 6 clouds to be drawn at random locations near the top of the screen. That is the sky. So then there's the first part of it, function draw clouds, then some more comments and some more code, then some more comments and more code. Essentially, if you write this way, you should be able to succeed on the performance create task.